everyone, especially to you, Sir Jerry. I am Jackie Lucy Lagos from BSED Mathematics 2 of Negros Oriental State University, Shatan Campus. Today, I will be discussing and elaborating the different differentiation formulas.
So there are 10.
As what we have discussed in our class, and I will be discussing and elaborating each one of them. I will be giving examples as well as explaining each one. So without any further ado, let's begin.
Now let's begin with differentiation formula number 1. So our differentiation formula number 1 states that the derivative or ddx of a constant is always equal to 0. So our differentiation formula number 1 states that the derivative of any constant is always equal to 0. So it's ddx of c is equal to 0. And c here is our constant. And when we say constant, these are well-defined numbers. For example, we have 7. We have 5. So these are well-defined numbers or constant. So we have -2, and our differentiation formula states that the derivative of any of these numbers is always equal to 0. So that is our differentiation formula number 1. So when we say ddx of 7, so that is equal to 0. When we say ddx of 5, it is still equal to 0. And when we say -2, ddx of -2 or the derivative of -2, it is still equal to 0. So that is our differentiation formula number 1. That's ddx of any constant is always equal to 0. Next, we will proceed to differentiation formula number 2. So our differentiation formula number 2 states that the derivative or the ddx of a constant, it's a constant and a function, is equal to the constant times the derivative of the function, du dx. Okay, so our second formula states that the derivative of a constant and a function is equal to the constant times the derivative of the function. So that is d dx cu is equal to c du dx. Now let's provide an example. Yeah, 3u raised to the fourth power. So our second formula states that in getting the derivative of a function and of a constant times a function, we will bring down the constant. So this will now become, so what will now this give us? This will give us, we have 3. Then derivative of u 4, so that is a power rule. So we will bring down the exponent. That's 4. 4 minus, so that will be now, so this will become 4, that's u cube. So that will become 3 times 4. So that is 12 u cube. So our derivative is equal to 12 u cube. So that is our final answer. That is, so we bring down first the constant, then we will get the derivative of the function before we proceed to multiplying them both. So that is our final answer. So f of x equals 3u raised to the fourth power will now become 12u cubed. So that is based on our differentiation formula number 2. Third, we have differentiation formula number 3. Third differentiation formula states that the derivative of the sum of two functions is equal to the derivative of the first function plus the derivative of the second function. So in this case, that's d dx of u plus b is equal to du dx plus dv dx. So we have the first function u and the second function v. So in order to find the derivative of the sum of these two functions, we will get the derivative of the first function plus the derivative of the second function. So let's proceed with an example.
Now we have function u which is equal to 3x and function v which is equal to 4x cubed. Now, using our differentiation formula number 3, we will proceed with the addition of these two functions and finding its derivatives. So, our d dx of u plus b will now be equal to d dx of 3x, which is our function u, plus d dx of our function v, which is 4x cubed. Now, this will give us so we have 3, which is the derivative of 3x, since x here has an exponent of 1 minus 1 that will become 0, and x raised to 0 is equal to 1, so 3 times 1, that's 3. Then we have the derivative of 4x cubed, so bring down 4, then we have to bring down the exponent, that's 3, then subtract 3 by 1, so that will become 2. So we'll now have 3 plus 4 times 3x squared. Then solving further, this will be equal to so now it will become 3 plus 12x squared. So this is our final answer with our given u is equal to 3x and v is equal to 4x cubed. The derivative of the sum of these two functions is 3 plus 12x squared. So this is derived through our differentiation formula number 3, and that is the differentiation of the sum of two functions. Next, we will proceed to differentiation formula number 4. For differentiation formula number 4, it states that derivative of the product of two functions is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So we have here d dx of uv is equal to u dv dx plus v du dx. Now let's provide an example. For example, we have u is equal to x squared, then v is equal to x cubed plus 4. So to find the derivative of the product of these two functions, we will use our product rule or the differentiation formula number 4. Now we will have d dx of u times b so this will now give us with d dx of u times b is equal to the first function, which is x squared, times the derivative of x cubed plus 4 plus x cubed plus 4 times d dx x squared, or the derivative of x squared. So this will further give us this will then give us x squared times 3x squared. So x squared, that's the first function, times the derivative of x cubed plus 4. So that will give us 3. Then subtract 1 from the exponent 3. That will give us 3x squared. Then 4 here is constant, which has a derivative of 0. So we'll just be left with 3x squared plus copy the second function x cubed plus 4 times the derivative of x squared, that will bring down to the exponent 2, then subtract 1, so that will leave us with 2x. Now, solving further, we have here x squared times 3x squared, that will be 3x raised to the 4th power plus x cubed plus 4 times 2x, so multiply each term, so that will give us x cubed times 2x, that is 2x raised to the 4th power plus 4 times 2x, that's 8x. And since 3x raised to the 4th power plus 2x raised to the 4th power here are like terms, so we can further combine them, so that will give us with. So solving them further, we have 3x raised to the 4th power plus 2x raised to the 4th power will give us with 5x raised to the 4th power, then plus 8x. So this is our final answer, or the derivative of the product of the two functions x squared and x cubed plus 4. So we have 5x raised to the 4th power plus 8x. And we derive this answer through using differentiation formula number 4.
Let's proceed with differentiation formula number 5. So we have here differentiation formula number 5, wherein the derivative of a function raised to the power n is equal to n times the function, then the power n minus 1 du dx. So we'll get the derivative of the function itself. So it is d dx of u raised to the power n is equal to n u, or the function n minus 1 times du dx. So let's give an example. So we have here u is equal to 3 times x raised to the power of 4 quantity squared. So that is our function. So in getting its derivative, we have now, following our formula, we have n here, that's 2, so bring down 2. Then u raised to the power of n minus 1, so our function is 3x raised to the power of 4. Then we will subtract 1 from its exponent 2, so that will give us 3x raised to the power of 4, quantity 2 minus 1. Then we will find the derivative of the function itself. So we have d dx of 3x raised to the power of 4. Solving further, we will have, so we have here 2 times 3x raised to the power of 4, since 2 minus 1 is 1, so we will be left with 1. So it's understood that if we want to write exponent here, it's understood that it has an exponent of 1. Then 3, here we have the derivative of 3x raised to the power of 4, so we will have 3 times, bring down the exponent 4 times x here, then subtract 1 from the exponent 4, we'll have 3. So we will have 3 times 4x cubed. Then simplifying further, we have, so we will now have 2 times 3x raised to the power of 4, that's 6x raised to the power of 4, times 3 times 4x cubed, that's 12x cubed. So this will now give us with 6 times 12, that's 72. Then x raised to the power of 4 times x raised to the power of 3, that will give us with x raised to the power of 7, since we are going to add the exponent. So this is our final answer. We have 72x raised to the power of 7. Now let's proceed with differentiation formula number 6. So our differentiation formula number 6 is the quotient rule. So we have, so the differentiation formula number 6 states that the derivative of the quotient of two functions is equal to the function in the divisor times the derivative of the function in the dividend minus the function in the dividend times the derivative of the function in the divisor all over the function in the divisor squared. So we have d dx of u over v is equal to v du dx minus u dv dx all over v squared. So let's provide an example. So we have here two functions u and v, so wherein u is equal to 5x plus 1 and v is equal to 3x minus 4. So the derivative of the quotient of these functions is derived by, so from our formula we have v, which is 3x minus 4, then the derivative of the first function, which is 5x plus 1, minus the first function, which is 5x plus 1, or the u, times the derivative of v, which is 3x minus 4, all over v squared, which is 3x minus 4 quantity squared. So we will now have 3x minus 4, that is our second function, or the value of v, times the derivative of u, which is 5x plus 1. So the derivative of this one will be 5, since 5x, so x here has an exponent of 1, then subtract by 1, so that will become 0 raised to the power of 0, which is equal to 1. So 5 times 1 is 5, and we have constant 1 here, which has a derivative of 0, so that will leave us with 5, minus 5x plus 1 times the derivative of 3x minus 4. So here 3x will give us with 3, and minus 4, which is a constant, so we'll just be left with 0. So that is 3 all over v squared, which is 3x minus 4 quantity squared. This will further give us with, so solving further, we have 3x minus 4 times 5, that will give us with 15x, since 5 times 3x is 15x, minus 5 times 4, that's 20, minus the quantity of 3 times 5x, that's 15x, plus 3 times 1, which is 3. So we have 15x minus 20 minus the quantity of 15x plus 3. So solving further, we will be left with, negative 23 over 3x minus 4 quantity squared. So we derive this using our differentiation formula number 6.
Now let's proceed to differentiation formula number 7. So we have the power rule. So we have d dx of x raised to the power of n is equal to n. So we'll bring down the exponent n, then x, then we will subtract 1 from the exponent n. So we have x raised to the power of n minus 1. So this is our power rule, wherein we are given an expression with a variable x and has an exponent, then we will bring down the exponent, then subtract 1 from the exponent. So let's give an example. So we have here f of x is equal to x raised to the power of 35. So using our power rule, we will bring down the exponent 35, then x, then subtract 1 from the exponent 35. So we'll have 35x raised to the power of 34. So that is what we are going to do. We'll bring down the exponent, then subtract 1 from the exponent, then we will derive with the derivative of our given expression. So that is based on our differentiation formula number 7. Now let's proceed to differentiation formula number 8. So we have here dy dx is equal to dy du times du dx. So if we will notice, there are three variables involved. So before we can proceed to this formula, first we need to find dy du, then we will find du dx, since this formula is applicable when there are two, or there is a system of equation given wherein we have the value of the variable y, or we have an equation for the variable y, then we have an equation also for the variable u. So let's provide an example. So here is how we are going to solve the equation. First, we need to find dy du. So we have the value of y is 1 over the quantity 1 minus u, the du of this function or this equation 1 over 1 minus u. We have a quotient of two functions, so we will use our quotient rule. So first, the denominator 1 minus u, then the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So we have here 1 minus u, copy, then the derivative of d, or the d du of 1, or the derivative of 1, which is a constant, so it is 0, minus 1, then the derivative of 1 minus u, so 1 here will become 0, and negative u will become negative 1. So we have here 1 times negative 1 all over 1 minus u quantity squared. So 1 minus u times 0, that is 0. So negative 1 times negative 1, that will give us 1 all over 1 minus u quantity squared. So we have here the value of u. We will substitute the value of u, so which is 1 over 1 plus x. So this will become 1 over 1 minus the value of u, which is 1 over 1 plus x quantity squared. Then we will find the common denominator for our function in the denominator. So that will be 1 plus x. Then 1 plus x divided by 1, automatic 1 here. So that will be 1 plus x minus 1 over 1 plus x. So that's quantity squared. So 1 minus 1 here, that's 0. So that we will be left with x over 1 plus x. So 1 over x over 1 plus x quantity squared. Then since we have a fraction in the denominator, we'll get its reciprocal. So that will give us with 1 plus x quantity squared all over x squared. So that is our dy du. Now let's proceed to du dx. So we need to find also our du dx. So we have here the value of u is 1 over 1 plus x. So d dx of 1 over 1 plus x is equal to, since this is a quotient of two functions also, so we will use a quotient rule. So we have denominator 1 plus x times the derivative of the numerator, which is 1, minus the numerator, that's 1, denominator is 1 plus x, so the derivative of 1 plus x all over 1 plus x quantity squared. So we have here derivative of 1, that's 0, so 1 plus x times 0 minus 1, then derivative of 1 plus x is equal to 1. Since we have 0 here, then we have positive 1. So we will be left with negative 1 over quantity of 1 plus x, or 1 plus x quantity squared. Then now, since we have the value of dy du and du dx, we can proceed with our formula, which is the derivative of, or dy dx, which is equal to derivative of y times the derivative of the function u. So we have here, we will just combine them and multiply them. So we have dy du, which is 1 over x quantity squared over x squared, times du dx, which is negative 1 all over 1 plus x quantity squared. So we can cross out 1 plus x quantity squared. So we will be left with negative 1 over x squared. So that is how we are going to use our differentiation formula number 8, wherein dy dx is equal to dy du times du dx if we are given like this system of equation wherein we are given the value of y and we are also given an equation for the value of u. So first, solve for dy du, then solve for du dx, then before we can combine them. And we will get an answer for our dy dx. So that is our differentiation formula number 8. Now let's proceed with differentiation formula number 9. So we have here dy dx is equal to 1 over dx dy. So in this case, we are going to find the derivative in terms of the variable y. However, we are given an equation in terms of the variable x. So, of course, finding the derivative of that equation, we will be arriving with dx dy. So, in order to find dy dx, we need to use this formula wherein we put 1 in the numerator all over dx dy. So, let's give an example.
So we have here an equation x is equal to 1/3 y cubed plus y. So just like what I have said a while ago, we are given an equation in terms of the variable x. However, we need to find the derivative in terms of the variable y. So here's what we are going to do. First, we need to find the derivative in terms of this variable x. So with its given equation, we have dx dy. So we have d dy of 1/3 y cubed plus y. So we will bring down the exponent 3, then times the constant 1/3, then subtract 1 from the exponent 3. We will have y squared, then the derivative of y, which is equal to 1. And since 3 and 1/3 can be crossed out, so we will be left with y squared plus 1. So we have now our dx dy, which is y squared plus 1. We can now substitute to our formula, which is 1 over dx dy. We have 1 all over the value of our dx dy, which is y squared plus 1. So we will be left with 1 over y squared plus 1. So this is now our dy dx, or the value of our dy dx. So this is now the derivative in terms of the variable y. This is derived based on our differentiation formula number 9. So we have dy dx is equal to 1 over dx dy. So we have 1 over y squared plus 1.
Now let's proceed to differentiation formula number 10. So we have here dy dx is equal to dy du divided by dx du. So in this case, there are three variables involved, wherein we will be given a form of equation in terms of the variable x and in the variable y. So before we can find dy dx, we must first find dy du, then dx du before we can divide them, and then we will come up with dy dx. So let's give an example.
We have here a system of equation wherein x is equal to 2u cubed minus 3u squared and y is equal to u cubed minus 3u. So before using our differentiation formula number 10, we must first find the derivative of each of these equations. We have dx du is equal to du of 2u cubed minus 3u squared, which will give us 6u squared minus 6u, since we will multiply the exponent 3 here, then subtract 1 from 3, so it will give us 6u squared. Then we have again 2 times negative 3, that will be 6, negative 6, then subtract 1 from the exponent 2, so it will leave us with u. So we will have 6u squared minus 6u. And since this can be factored out, then we can factor this. So we have 6u times the quantity of u minus 1. Then we will find dy du. So we have d du of u cubed minus 3u. So again, power rule. Bring down 3, then subtract 1 from 3. So that will leave us 3u squared minus 3. Since u here has an exponent of 1, then subtract by 1. So that will become 0. And u raised to the power of 0 is equal to 1. So negative 3 times 1 will leave us with negative 3. We will be left with 3u squared minus 3, which is equal to its factor 3 times the quantity of u squared minus 1. And u squared minus 1 can still be factored out. That will be 3 times the quantity of u plus 1 times the quantity of u minus 1. Then, after finding dx du and dy du, we can now solve using our differentiation formula number 10. So, we now have dy dx is equal to dy du divided by dx du. So, our dy du here is 3 times the quantity of u plus 1 times u minus 1. So, let's write it here. Then, we have dx du, which is 6u times the quantity of u minus 1. So, we also have here u minus 1. Then, if we will notice, we have a common factor, which is u minus 1. So, we can cancel them out. Then, we have 3 and 6. So, common factor is 3. Then, we will be left with 2u. So, our final answer is dy dx is equal to u plus 1 all over 2u. So, wherein u must not be equal to 1. Since if u is equal to 1, 1 plus 1 is 2. Then, 2 times 1 is 2. It will leave us with 1, which should not be the value of our dy dx. So, our final answer is dy dx u plus 1 all over 2u. So, this is derived through our differentiation formula number 10.
There you have it, everyone. Those are our 10 differentiation formulas that we have discussed in our class. So I hope you were refreshed from our discussion, you were learning something, and I hope you will continue to learn. This is still Jackie Lucy Lagos. Thank you and God bless.